Safari Stan, let's go exploring today. Safari Stan, we'll learn about the world and sing and play. Science Susan will help us along the way. Then we'll pick up Bio Betsy and go on a safari today. Safari Stan, Safari Stan, Safari Stan, let's go exploring. Safari Stan, Safari Stan, Safari Stan, let's go exploring today.
Safari Stan!
Hey kids, I'm Safari Stan, and welcome to my show. Today on Safari Stan, we're going to be learning about invertebrates. See if there's any ones around here. Oh look, an invertebrate! Let's get this back to the lab. And now we're on the way to my lab. I can't wait to show the girls what we found today. This is Bio Betsy and Science Susan. Hey girls,
Hey, Safari Stan.
look what I found, an invertebrate.
What's an invertebrate, Safari Stan?
Oh, an invertebrate is an animal without a backbone. In this case, an insect.
Today, girls, we're going to be talking about invertebrates and how they are affected by gravity.
Gravity? What's gravity? And what does that have anything to do with invertebrates?
Well, you see here, gravity is the force that helps keep you down when you jump. Notice how I didn't fall off the earth that time. And how they're related to insects? Well, in the legs, there are these things called statocysts. And we'll learn more about that in just a bit. This is a statocyst.
Our invertebrates need statocysts to know which way is down when they're flying. This ornament is like a statocyst. Inside the statocyst, which is an organ, there are many, many little statolith, which are like little grains of sand. And as the insect is moving, like this, the statolith move and adjust. Now, where the glass is on the organ, there are millions and millions of little hair called cilia. Each cilia receives a message when the statolith is moving over it, and it tells the body which way is down. Once the cilia get the message from the statolith, then it will send their message to the ciliated receptor cells, which basically receive the message and tell the sensory neuron what's going on.
So how does the brain receive all that information from when the cilia move?
Well, there are these things called sensory neurons, also known as axons, and it kind of works like this. You want to take this cup? Kids, this is an experiment that you can try at home. You just take 2 cups, piece of string, pull it really tight, and you can send messages across. So, if this is the statocyst, and this is a sensory neuron, that's the brain. So it sends a message and says, "Hey brain,
Yes.
guess what?
What?
We're going up."
Oh, okay. I will adjust my position.
This process right here is always going on inside the insect. As gravity is always pulling down on us, these will always tell the insect which way is going right, which way is going left, and which way is up or down.
So this is how it works?
Yep.
So we learned a lot today. Let's review.
So, this is how gravity affects our invertebrates. Constantly inside our invertebrates we have the statocyst, and in the statocyst the statolith are being affected by the gravity. Because gravity is always pushing down on them, they're always facing down, no matter which direction it turns. And so, as it's turning each direction, it's affecting the cilia, which are the little hairs, and telling the cilia where the statolith is moving to. As this is moving, it sends messages to the brain via our sensory neuron, telling the brain which way is up or down. Thanks for joining us on our adventure today. See you next time on
Safari Stan!
Safari Stan.